Okay, good morning. I guess good afternoon. Go ahead and get out your multiple choice worksheets. I'm going to go through the answers. You'll be able to see the work, and I probably won't go slow enough for you to be able to see the work. So if you need to either pause this or come back to it and pause it and look at the work, that might be a good idea for you. So number 1 is C, 2E, 3D, 4D, 5D, 6B, 7D, you need to use U substitution, 8A, U substitution there also, 9A, 10D, 11A, 12D, 13A. Remember, the derivative of an integral is just the function itself. 14 is E. If it's not just X, we have to apply the chain rule. 15B, 16A. Remember, this is how we find an area of a trapezoid, and we have to do that over and over. 17, we have to use some geometry to help us. E, 18B, 19C. Okay, out of 19, just put at the top how many you got right. And like I said, if you need to come back to this and look at any of the work, you can pause it at any time and go ahead and look at the work. Okay. I'm going to have the sub go ahead and hand out the Rub-a-Dub-Dub activity sheet. You can have your calculators out, so go ahead and get those out also, making sure that they are in radian and function mode. Okay. Remember, if I ever move on too quickly, you do have the capability of pausing this video. So let's go ahead and read what's happening. Rub-a-dub-dub, we have a leak in the tub. At the beach last summer, we rented a house with a hot tub. As soon as I turned it on, though, it started to leak, and I decided to try to fill it with a hose. Suppose that the tub was leaking at a rate of radical 2t plus 3 gallons per minute, and the rate of the water from the hose was 6 gallons per minute. The tub initially had 400 gallons of water in it. Okay. So, we are given the leak in terms of a rate. Okay. So the derivative of the leak is 2t plus 3. All right, so how much water has leaked out during the first hour? So this is the rate at which we're losing water, and it is in gallons per minute. So how would we determine the amount of water that leaked out during the first hour? We would need to integrate from 0 to 60 of 2t plus 3. Remember, we're talking about a rate, so if we go backwards, then we get back to the original function. So if we're talking about gallons per minute, taking the antiderivative of that, going backwards, is going to get us to gallons. Okay, so you're going to need your calculator for this. Go ahead and math 9 to figure out what this is. I want you to remember how to use your calculator. Math 9. So we should get 452.980 gallons. Okay. Now, how much water was added into the tub in the first hour? Well, what was happening? How fast was the water being added? And we're talking about the first hour. So write down how you think we should find it. Did you write down 6 times 60? Because the water is being pumped in at 60 gallons per minute. 6 gallons per minute times 60 minutes. So we have 360 gallons being added in. Okay. So how much water was in the tub at the end of the first hour? Go ahead and set that up for me. We started with 400. We're losing 452.98 gallons, but we added 360. So we have a total of 307.02. Okay, what is the largest amount of water in the tub during the first hour? So I want to point your attention to the word largest amount. What are we trying to find? Okay, we need to find some sort of maximum in order to be able to determine what that amount is. Okay. So the first thing that I want you to do is set up the equation that we need to find the maximum of, and then stop. Set up the equation we need to find the maximum of. Okay, so we're talking about the amount of water. I'm going to call it Y, and I'm going to let X be the number of minutes. Okay, so here we go. We start out with 400 gallons. We're going to add 6 times the number of minutes with our hose, and then we're going to subtract the integral from 0 to x of radical 2t plus 3 dt. Now, we need to make sure that since t is inside of our integral, then we have a different variable in the rest of our equation. okay? Since we have an integral in our equation, those two have to be different. So what I want you to do now is take some time, and we need to find the maximum. So go ahead and use the first derivative test to find the x value in which the maximum occurs. So I get x is 32 halves for my critical point. Here, I have the derivative. I then set the derivative equal to 0. Add the radical to the other side. Square both sides. Solve for x. It is important that we make sure that this is a maximum, that indeed, when we plug values in to our derivative, we go from positive to negative. Now we can actually determine what the maximum amount of water is by taking this and plugging it in to this up here. So when we actually evaluate this at x equals 32 in your calculator, what do you get? You should get 428.7 gallons. Okay, when will the tub ever run out of water? Write down how we would need to set that up. So this equation that I'm writing in purple, this is our amount of water equation. And if we're going to run out of water, we want this to be 0. So my best advice to you would be to go ahead and rewrite this equation by taking this integral and actually performing the integration, okay? And then plug in x minus plug in 0. Okay. Then I would actually graph this and find the zeros. Okay. Okay, so you should get X is 104.5 minutes, which would translate to over an hour and a half before you would run out of water. Okay, probably wouldn't be very warm water if you're using the hose to fill it up, but that's just what would happen. Okay, so the sub is going to hand you your last free response homework. Okay, it looks like, let me pull it up here. I think you can do it without a calculator for both of them, but let me just double check, okay? Okay, I think you can do both of them without a calculator, but number 2 would probably be the only one that you would maybe need to reference your calculator, but I think you can do both of them without your calculator. So tomorrow we will, quote unquote, go over that, and then we'll do some calculator work tomorrow, and then we will review Friday, Monday, for your test that will now be Tuesday, Wednesday instead of Monday, Tuesday, which will be nice that we'll have review on Friday and Monday for you. But with our power outage, not power outage, but the air conditioner outage from Monday, not having school, that will push our test back one day. Just FYI. So good luck on your worksheet. And